on homework. Hopefully this isn't too bad. That did not copy quite the way I want. At any rate, question 6 and 7, and really most of these are quite conceptual in this chapter. This was an object going to the right, but it started behind or to the left of 0. This was going up, but it started below or under 0. So both these actually have the same answers. Position was negative, velocity is positive because we think of right and up as positive, and acceleration was also positive. And this gave us an area of an object going, I think, 60 miles an hour, and then slowing down consistently but not instantly to 30 miles an hour. So any of the hash marks here just mean that these are the same size. So these three are the same size. So it slows down over a little bit of time. Here we had 3 positions, and it was asking if the average speed between 0 and 1 was greater, less, or equal than the speed between 1 and 2. So the speed between 1 and 2 is greater because there's a greater distance between 1 and 2 than between 0 and 1. However, if this asks for velocity, because it appears to be going to the left, and velocity pointing to the left is negative, it would be a more negative velocity, therefore a lower velocity between 1 and 2 than 0 and 1. So velocity is a vector quantity, speed is a scalar quantity. For part B, average acceleration vector, if we were thinking about going to the left and speeding up, would be an arrow pointing to the left. This was asking about something that was dropped from a 3rd-story building, bounced, and came up only 2 stories. So this is not an elastic collision. It does not have the same kinetic energy leaving the ground as it has going in. Gravity going down accelerates it. I only need 1 arrow to show this constant acceleration down here, and then 1 arrow showing constant acceleration down here. But at this spot at the very bottom, there's a great upward acceleration because it's a change from a downward to an upward velocity in a very short amount of time. For 32, there's a bunch of ways you could do this. If you have different roads with different speed limits and you're on them for different times, it could get quite complicated. But overall, average speed in its simplest form is just distance over time. Velocity is displacement over time. So I go a little over 9 miles, and it's about 18 minutes. So I go a little actually more than 9 miles and a little less than 18 minutes on a good day. Probably this is a little under my average speed, but that's pretty close. So 30 miles per hour. 18 minutes is 0.3 hours. Notice I'm doing the factor label conversion here. I'm showing you how I get from miles per hour to meters per second. It's about 13 or 14 meters per second. We don't want a bunch of decimals with these answers because they're quite uncertain. Obviously, your trip to school day to day can vary a few minutes. This one was asking about Bruce Blade's time to reach the blue line. So that's going to end up being 5 meters and over a velocity of or a speed of 4 meters per second. So it's going to take him 1.25 seconds to do that. When the puck has to go 20 meters in that same time, so now that distance divided by time gives us the puck speed. Hey, they tried me to tell a story with this. So I've got a dead goose dropping out of a tree, accelerates downward at a constant acceleration, hits the ground, comes back up, but not as high. This problem 47 is very similar to the description that they wanted you to have with this one here, problem 16. So you're accelerating downward except at the very bottom where there's a great upward acceleration. Problem 52, I've got VA and VB. It looks like the velocity of B is starting, or the position of B is starting ahead or in front of A, but the acceleration is lower, so this arrow is shorter. And they finish at the same time and at the same place. So I said that Brandon Waite was running to the right, that's VB, starting closer to the finish line than his brother Andy, VA, and they both finished at the same time, but notice that Andy would have a higher speed. So if the race was a little longer, Andy would have won the race. And a story here, notice that for this one, this graph was a vertical position graph versus time. So I have to have someone going up the stairs. I had Samantha walking briskly up the stairs for 8 seconds. Because 2 meters per second is like almost 6 feet per second upward. And then running up the stairs the last 4 seconds, and then not moving vertically at least during the middle 8 seconds. So hopefully those are okay.